Welcome to all students. I am Professor SSI. Today we discuss about APM numericals. Before solving these numericals, we discuss about steps of general APM process. So, in general APM process, the solution of a general continuum problem by the finite element method follows an orderly step-by-step procedure which refers to the static structural problem. The step-by-step procedure is as follows. In step 1, discretization of the given continuum, the first step in APM is to divide the given continuum into small regions called finite elements. The analysis is carried out for each of these elements. The points where properties are to be determined to an element are called nodes. The process of discretization of continuum is simple. For the continuum initially having infinite degrees of freedom is discretized into n number of triangular elements having 6 degrees of freedom as shown. Figure shows the triangular element having x displacement q1, q3, q5 and y displacement q2, q4 and q6. This is the very simple step 1. In step 2, selection of displacement model. For the continuum discretized into number of smallest elements, the displacement variation over each of the element is unknown. Hence, a displacement function is required to assume for each of these elements known as displacement model. There are two kinds of displacement function that could be assumed. In polynomial displacement function, trigonometric displacement function. Out of the above two functions, one that is preferred for APA is polynomial function for its ease of mathematical calculation. There are the displacement model selected is governed by three conditions: type and order of functions. The type of function selected may be polynomial or trigonometric function. The order of the functions that could be selected, if nth order, then the solution for the problem is exact. An approximate solution could be obtained by truncating the polynomial to finite order. In step number 3, there is derivation of elemental matrices and load vectors. The elemental stiffness matrix and load vector for each element are derived using various methods such as direct method and potential energy method. The equilibrium equation for an element is given as K equivalent equal to Q equivalent, that is F equivalent, where Ke is the element stiffness matrix, Q is the displacement vector and Ap is the element load vector. After this, we discuss about assemble of element equations to obtain global equilibrium equations. As the continuum is composed of several finite elements, the individual element stiffness matrices, displacement and load vectors are assembled to obtain the global equilibrium equation. The global equilibrium equation is given by K into Q is equal to F, where K is the global stiffness matrix, Q is the global displacement vector, F is the global force vector. After this, there is applications of boundary condition. Various boundary conditions are imposed prior to solution of problem to obtain non-singular solution. There are three methods of applying boundary conditions for AP problem, that is elimination method, penalty method and multi-point constraint method. In step 6, to determine the unknown parameters, after imposing the boundary conditions to the global equilibrium equations, unknown parameters such as nodal displacement, element strains and stress can be obtained. So, there are, repeat again the steps. In steps, discretization of given continuum. After this, selection of displacement model. After this, find element stiffness matrix. After this, assembly of global stiffness matrix. After these, apply boundary conditions, and after these, determine unknown parameter. These are the steps. So, in this problem, only the steps is applied, then we get the solution of this problem. This problem is three dissimilar materials are friction welded together are placed between rigid end supports if forces of 50 kN and 100 kN are applied as indicated. Calculate the moment of the interfaces between the materials and the forces exerted on the end support. In this is the given data diagram. This is the for aluminum, for brass, for steel. These value given: area, length, modulus of elasticity. This is the analysis. Only the formula is applied, and after this we get the forces like F1 is equal to minus 48 kilonewton, F4 is equal to minus 45.2 kilonewton, and X2 is equal to 0.048 mm, and X3 is equal to 0.323 mm. So in this is a very simple problem. Only apply these boundary conditions. After these applying boundary conditions, we get the solution. So these 7 steps are very important for solving the APA problem. I am repeat again these steps: discretize of the given model, selection model, find element stiffness matrix, assemble global stiffness matrix, apply boundary conditions, determine unknown parameters. Thanks all of you.